Okay, so what if I told you the world's biggest fishery? I mean, the single most caught fish on the entire planet is a species most of us have, well, never even heard of. You've definitely never seen it on a menu. And yet this one tiny fish is the invisible foundation of our whole global food system. So yeah, let's dive in.
All right, here's the roadmap for this explainer. We're going to uncover the world's biggest catch, and you'll meet the little fish behind it all. Then we'll look at the incredible ocean engine that makes it all possible, and see how that whole system's kind of on a knife's edge. And finally, we'll check out how scientists are trying to save it, and what that could mean for, well, for everybody.
So let's just jump right in with that big question. What fish do we pull out of the ocean more than any other? When you think about massive global fishing operations, your mind probably jumps to the big names, right? You know, the stuff you see in the supermarket. Tuna, for sure. Salmon, maybe cod. These are huge, huge industries. But are any of them actually number one?
Well, the answer, according to the Food and Agriculture Organization, is a big nope. The winner, and honestly, it's not even close, is the anchoveta. Look at these numbers from 2022. We're talking almost 5 million tons of this little fish. That's 1.5 million tons more than the runner-up, Alaska pollock, and way ahead of skipjack tuna. Which brings us to a really important question. Who on earth is eating all of this anchoveta?
And that question, that's really the heart of the story, because the answer is definitely not what you're thinking. See, you're not going to find the Peruvian anchovy next to the salmon at your local fish counter. It's not in your fish and chips, it's not in your sushi. Almost none of this gigantic catch is actually meant for us to eat directly.
Instead, it gets turned into something completely different. In just an average year, this one single fishery produces about 20% of the entire planet's supply of fish meal. The difference here is just it's night and day. The anchoveta isn't a main course, it's an industrial ingredient. It gets processed, ground up, and turned into this high-protein powder, that's the fish meal, and omega-rich fish oil. So where does all that stuff go? Well, it feeds the world's farmed fish. We're talking salmon, shrimp, you name it. And it also enriches feed for livestock like pigs and chickens. So in a way, this one tiny fish is feeding all of us by powering the farms that put food on our tables. It's completely hidden in plain sight. Okay, so that leads to the next big question, right? Why? Why this fish in this one part of the world and in such absolutely mind-boggling numbers?
The answer isn't really about the fish itself, it's about where it lives. The Humboldt Current System, this stretch of ocean off the Pacific coast of South America, is one of the most productive marine ecosystems on the entire planet.
And the engine that drives this whole system is a process called coastal upwelling. It's a beautifully simple concept, but it's incredibly powerful.
Here's how it works. You've got these strong winds that blow along the coast, and they push the warm surface water away from the shore. To fill that gap, cold, dark water from the deep ocean, which is just packed with nutrients, gets pulled up to the sunlit surface. And when that nutrient-rich water hits the sunlight, boom, you get a massive explosion of phytoplankton. That's the very bottom of the food web. The anchoveta just feast on this stuff, and their population goes through the roof.
But this incredible engine of life, it has a dark side. Its immense power is matched only by its fragility.
Yeah, the very same forces that make the Humboldt Current so unbelievably productive also make it incredibly unstable. It's an ecosystem that really lives on a knife's edge, and it's prone to these huge, dramatic swings. The most famous example of this is El Niño. During an El Niño year, those super important winds weaken or even reverse direction. And that upwelling engine, it just sputters and dies. The cold, nutrient-rich water gets replaced by a warm, nutrient-poor blanket of water from the west. And for the anchoveta, it is a total catastrophe. The food chain collapses, and their population can just plummet.
Now, El Niño is a natural cycle, but scientists are now looking at a much more permanent and unpredictable threat: climate change. It's expected to basically supercharge the system's volatility. We're talking more intense El Niños, productive zones shifting south, and the water warming up, forcing fish to move. On top of all that, it's also expanding what are called oxygen minimum zones, areas with so little oxygen that they can't support life. It's literally shrinking the anchoveta's world.
So, let's recap. You've got the world's biggest fishery, it's vital to the global food supply, and it's in an ecosystem that is both naturally shaky and now under serious threat from climate change. What do you do?
This is honestly one of the biggest challenges we face in conservation and resource management today.
How can you possibly plan for a future that's becoming harder and harder to predict?
Well, the answer, it turns out, is to stop looking at the ocean in little isolated pieces. Scientists from Peru, Chile, and Ecuador are launching this really groundbreaking collaboration. The big idea is to pool all their data, all their expertise, and their resources to see the Humboldt Current not as 3 separate national zones, but as one single connected system.
This roadmap here, it lays out the whole vision. Think of it like a feedback loop. It starts with sharing info to build a common understanding that leads to better data collection on a shared platform. This improved science then feeds into an early warning system, which allows for smarter adaptive management, and that ultimately makes the entire fishery more resilient. It's a virtuous cycle.
And the ultimate goal has a name: SAPO. It's a hugely ambitious plan to create a unified observation, prediction, and warning system. So, step 1, break down the data silos. All the info from buoys, satellites, research ships from all 3 countries flows into one shared platform. Step 2, use that massive, unified data set to build much better forecasting models. Step 3, turn those forecasts into clear early warnings. And finally, step 4, use those warnings to make quick, science-based decisions, like changing fishing quotas or closing certain areas, before a crisis like an El Niño can wreck the whole stock.
And this all brings us to the final, and maybe the most important, piece of this whole puzzle: what this means for the rest of the world.
Because, you see, the story of the anchoveta is about so much more than just one tiny fish. It's about a shared resource that crosses borders. It's about a vital industry facing a future that's getting more and more unpredictable. And it's about a group of nations choosing science and cooperation over competition. You could say it's a test case for our time. As climate change starts messing with ecosystems everywhere, could this collaborative, data-driven, adaptive approach, could this be the blueprint we need to manage all of our planet's most critical resources?